Great, I think you're good to go whenever you're ready, James. Thank you.
Okay, right. Okay, folks, well, thanks for coming along. The name of my talk tonight is Dykes, Sills and Cone Sheets. I think it was originally given as Dykes, Sills and Cone Sheets for beginners, and that's basically what it is. There's nothing, hopefully, too technical in it. It's just to explain these important, they're called, I mean, they're referred to as minor intrusions, but places like the West Coast are absolutely full of them, and they're a major feature of the geological landscape. So what I want to do is just basically look at these things, explain what they are, what they look like, where to see them, and I've got a wee virtual field trip at the end. So thanks to Angus again for using his Zoom account for hosting this, and we'll get going. There'll be a chance to ask questions at the end. So first of all, as always, I usually talk about sources of information that we can use for this. One of the, I mean, these are the main ones that I've used for this talk. We've got The Paleogene Volcanic Districts by Emilius and Bell. That's a really thorough book. It's absolutely packed with information on this subject. We've got Mull, Iona and Ardmurchan, The Landscape of Stone. That's quite a good introductory text. There's Mull in the Making, which has been out for a long time now. Excellent little book, gives a lot of good information. There's Mull and Iona, Landscape Fashioned by Geology by SNH. That's no longer in print, but you can download it as a PDF. And quite important for looking at minor intrusions and things like that are the maps. Now I've just got the cover of the Eastern Mull map, but there's BGS maps for North Mull, Stafford, the Ross of Mull, and other areas. And you can look at them online. They're available to view online. So you can't download them and save them, but they're available to view. Give you some of the web links. This is the Paleogene Volcanic Districts. Most of the text is actually available online. And that's the URL at the bottom. It's probably easier just to go to Google and hunt for it. Yep, so there's a lot of diagrams I've got from that over the series of these lectures. The Landscape Fashioned by Geology, Mull and Iona, again, that's the download link for it. If you want to go to SNH, well, Nature Scott it's called now, to have a look at that. And I mentioned the BGS maps. The BGS website has got a maps portal where you can go on and look at them and look for any geological map for anywhere in the British Isles, really. So there's lots of good material there. The memoirs of the survey are also available online, and that's one that's worth looking at. So the questions I've got for tonight are: what are dikes, sills and cone sheets? What do they look like? Why are they important? How are they formed? Where are they found? Where can I see them? We'll take each intrusion in turn. I'm mainly going to concentrate on dikes because what applies to dikes also applies to the other ones in quite a bit. And there's loads of images and pictures to illustrate it, loads of pretty photos. Now here's a definition from the United States Geological Survey. Dikes, you've got the American spelling as well, notice. They're tabular or sheet-like bodies of magma that cut through across the layering of adjacent rocks. They form when magma rises into an existing fracture or creates a new crack by forcing its way through existing rock, then solidifies. So that's as good a definition as any, but we'll see a lot more of this as we go through these slides. Here's a good wee diagram showing you what volcanic activity looks like at the surface and underneath. You've got a big body of magma underneath, and that can pour out at the surface as a volcano. It can also get intruded into the rocks underneath in these various ways. And the rocks underneath the surface are what are called intrusive igneous rocks. These are ones that don't make it to the surface, they solidify under the ground. Extrusive igneous rocks are things like lavas and ash and pyroclastic stuff that comes out of the surface. So if it pours out a volcano, it's extrusive. If it solidifies underground, it's intrusive. And you can see from here that dikes are the ones that cut across the strata, and sills are the ones that run in between them. And there's also some other good names as well. Now I've got another picture here, which is actually slightly better. It gives you a bit more detail. There you've got a feeder going up into a volcano, and you've got various things coming off at the sides. You've got dikes going up, and you've got a sill coming out here. You You've also got other wonderful named things. There's a thing called a laccolith, which is this inverted thing like that. You also get things called facoliths, and there's the saucer-shaped ones called a lopolith. So I've often joked with people, in geology, you might not learn much about geology, but you'll get some cracking words for Scrabble. Sills are underground, and that you only see them when erosion reveals them, whereas dikes can be seen at the surface anytime when they've burst through. So one of the things that points out in this diagram here is that all this igneous activity underground, all this hot material, it can affect the rocks, and it does what's called thermal or contact metamorphism. So that the rocks get heated up by all this hot material. And they can also get pushed up. As you can see here over on the right, the effects of all this stuff underneath can distort the strata that's up above. And we've got that in Mull, around, especially in the southeast of Mull, where all this igneous material has been pushed up. The rocks have been seriously folded, and this can be traced around almost in a complete circle. So that what's happening underneath can affect the rocks at the surface quite dramatically. This is what a dike looks like erupting at the surface. This is a fissure eruption, again from a USGS photo. And it's like a line, it's like a curtain of fire as this material pours out at the surface. And eventually when that fissure that's coming out of solidifies, you'll have a dike. So let's look at the appearance of dikes. They can vary quite a lot. They're generally linear, but they're sometimes sinuous. They're not necessarily straight. They can form a wall-like structure, or they can form a ditch, like a channel. Sometimes you get both. You'll get part of it that sticks up like a wall, another bit that's like a channel or a chasm. Sometimes they're exactly the same level as the country rock. The country rock is what they're intruded into. So it's just exactly the same, just like a stripe on the rock. And frequently they just disappear. There are some classic examples of this where the best one I can think of is probably the famous dike at Calgary Bay in Mull. It's this beautiful thing, which we'll see later. It sticks out on the cliff face. There's this nice solid wall of rock. And then you go up the hill to try and find it, and there's just no sign of it. It's just gone, it's disappeared. So I've got some examples of this to show you. This is Arran, where Angus is just now. And I don't know if you're planning on going down here, if you've been there yet, Angus, but this is Kildonnan. And there's what's called a dike swarm. Very often dikes, you don't just get one or two, you get a whole pile of these things, all following the same line. And these ones are forming these straight lines going out to sea. It's really distinctive. This is one of the best examples of a dike swarm. And if you look at it on the satellite image, this is from Bing. Bing and Google both have satellite images. I quite like the Bing ones. I think they're better than Google's. But you can see all the dikes stretching out to sea there, and they're all roughly following the same sort of line. So these were straight dikes. This one here that you can see, this is a sinuous one. This is at Ardmore Point in Mull, and it's following a sort of twisting path. I mean, it all depends on the rock that it's getting intruded into, if it offers much resistance or whatever. But they'll find their way through. So some of them are quite curvy like this. And here's one. This is an absolutely standard Mull dike. This is, if you want to see a typical Mull dike, this is what it looks like. It's intruded into lava, which is what this stuff is. This white spotted material is around the sides. And this is the dike sticking up like a wall of rock going across it. The lava, the spotting in the lava is because of minerals contained within it, what are called amygdales. And these are little crystal-filled voids in the rock. Again, that's really common in Mull. And in other places as well, up the west coast where you've got these volcanic centers, this is quite common, this sort of stuff. Here's a dike, a real cracker, this one. This is at Morvern. We're over on the mainland now. That's my wife standing in the hole in the middle of it. It's called Clachnacreacha, which means the wall, the stone of the boundary. And I think that's the line of an old march. There's an estate boundary runs down there. It's an anciently named thing, but something's called the wishing stone as well. And it's got this hole in it just where it's eroded out. And there's another view of it there. And there's this information board telling you about it. Because Morvern is part of the Lochaber Geopark, there's also some good signage telling you about these things. So that's Clacna Creek. It's well worth a visit if you're ever over that way. It's quite a remarkable structure. But that's a classic dike of the Mull swarm. I know it's on Morvern, but it's classed as a Mull swarm dike. And there's lots of these things that run in a northwest, southeast direction. That's the prevailing trend for them. Here's another one. This is in Cumbria. This is called the Lion Rock. This is a beauty of a thing, this. And again, it's got holes in it. This is, we're seeing the edge on here, but that's a face on rather, but that's one of the Mull swarm dikes. And if you're to measure the orientation of that, that also would be northwest, southeast, which is the way most of them go. I said that some of the dikes don't stand up as a wall of rock, but they actually weather out to form a chasm. Now this is one at Finnefort, Isle of Mull. It's in the Ross of Mull granite, this one. And you can see how it's completely eroded out to form a sort of channel in the hillside. Sometimes it can be quite hard to actually see the rock, the dike rock itself, because it's covered in vegetation or boulders or stuff. But down on the shore here, you can actually see the rock, an actual rock that it's made of. And here's another one. Here's a good dike. This one's at Portfield near Croggan, again, Isle of Mull. Now the Croggan area is fantastic for seeing dikes. There's just hundreds of the things down there, and that's a nice one. That's it almost looks man-made. This type of thing, it's like a wall of rock. But that's a perfect example of a Paleogene dike. Sometimes, and again, this is at Croggan, the dikes weather out, so you're not left with you don't have a wall standing up. You've got this chasm. So you've got this one here, and then not far from it, you've got this one. But you'll see this one here has got a little bridge across the gap formed by a bit of the dike rock that hasn't eroded out. So for some reason, that little bit's a bit stronger, and it's in the gap there. The Croggan coast is a fantastic place to see these things. And I mentioned that some of them are possibly the same hardness as the country rock itself. This is a place called Scarisdale in Mull. That's Loch na Keel in the background there. And this one, as you can see, it's just like a stripe across the rock. It's the same hardness. There's no weathering out. There's no standing up. It's just the same. It's just this line across the rock. So they vary quite a bit in appearance. So if we look at the dimensions of these things, some of them, this is from Emileus and Bell, this information here, the Paleogene volcanic districts. Most of them are less than 1 meter in thickness. Some get between 2 and 10 meters, and you can get thicker ones. There's one near, well, down from Croggan and Mull, that according to the BGS map is over 60 meters wide. I went to look at that one, and I don't reckon it is 60 meters. I think it's about half that, but it's still pretty wide. And there's one in Muck, apparently, and I've never been to Muck, a place I'd love to go and see, which is about 100 meters across. Now that's huge. That's very, very wide for a dike. Again, that's mentioned the Paleogene volcanic districts. So, that is a seriously wide dike. That's very, very unusual. The length of these things, they can go for several kilometers. They can go for hundreds of kilometers. And there's lots of very short ones you'll see on the map. Now, the reason that they're short is not because they're just little short dikes. It's because they've found them in stream sections and places like that. And that's the only place you can actually see them. You can only see a small section of it. So what's on the map is just what they've been able to see. There might be a lot more than that. We'll see that later. Get some photos of these things. These two dikes, there's a thick one. That's about 5 meters wide, that one there. That's near Tobermory, and a really good bit of coast up the path that goes to the lighthouse. There's some really nice dikes down there. There's about 10 of them over a space of about half a kilometer. There's a lot of dikes there. That's a good wide one. You can see a sort of columnar structure to it across the way. We'll see a bit of that later as well. And not far from it, there's this other one, which is quite sinuous, but it's quite small. It's only about half a meter wide. So they're quite different, but very close together. So these things can vary quite a lot in their appearance over a short distance. This is the one that I was telling you about that claimed to be 60 meters wide. It's an incredibly remote place round from Croggan and Mull. It's on the Lagan Peninsula, and it's called Rua Treigal, and it's mentioned on the map as 60 meters wide and terminating in the cliff. Now I went to see this thing, and this is it here. And I reckon it's only about 30 meters wide. I wouldn't say 60. And certainly it does terminate in the cliff. So, but whether it's truly a dike or not, I did have some debate with some people about this, and I reckon it might just be what's called a plug, just a thing that's come up and not gone any further. But the rock itself is particularly nasty. If you look at this here, it's heavily altered. It's very brown. There's been a lot of olivine in it that's been altered. It's quite a coarse rock, but the contrast between that dike rock and the other rock round about, which is mainly lavas and things, it's really, really obvious. This thing stands out like a sore thumb. But it's one of the most remote places imaginable. It took a whole day to get there and back. So, but yeah, it's marked on the map, as I said. This is muck. I was talking about muck. I'm not honestly sure where that big 100-meter dike is. If you look at the map, you'll see that all the dikes are indicated as the same width. And that's just a limitation of the map making. If you indicated dikes as their actual width to scale, they'd be absolutely tiny. They'd be like little single hairlines drawn on the map. So, but you can see there's lots of them going northwest, southeast, which is fairly standard for these things in this part of the world. Muck's quite an interesting place. I'd love to see. I haven't been to it yet. One of the things that's pointed out in Emilius and Bell is that the muck dike probably acted as a feeder for lava flows. So this is what they reckon. Some of these dikes would have been feeders for lava flows at a higher level that have now been eroded away. So that's muck. Here's a map of the west coast showing you the major dike swarms and their orientations. And as you can see, it's mainly northwest, southeast, and that reflects the tectonic stress regime that was in place when all this was happening. It's about 60 million years ago, when the Atlantic Ocean was opening up. You got tectonic plates moving apart, and the dikes have exploited the weaknesses caused by that. And here's a famous old map. This one's, see, there's loads of places. This shows some of the dikes that spread from like Mull and go across the southern uplands and into the north of England. So some of these do go for quite a distance. And they can go considerable distance with some of these dikes. They're quite remarkable. And there's little bits of dike elsewhere down in England here and over Northern Ireland. So they're and out in the Western Isles. So the dikes associated with Mull, Skye, and Arran, whatever, they're as I said, they're described as minor intrusions, but they're actually a major geological feature. I mentioned lots of little dikes marked on the map, and here's a good example of this. This is in North Mull. You've got this stream coming down here, and you can see all these tiny, tiny little sort of reddish pink lines cutting across. That's dikes that have been mapped on the map. Now, they're not just tiny little short dikes that end at the stream. They obviously go further, but it's just that streams are great places to actually do geological mapping because you can see bare rock there. Probably the most of this territory round about here. I haven't been to this particular location, but I suspect it's just peat and bracken and grass and stuff like that, and not much bare rock to see. So that's just what's been mapped. So that's why these look like that if you see them on the map. It's not because that's the total length of them. There are some other longer ones that have been indicated. As you can see, there's a longer one there. This looks like a bit of a longer one here. So that's what's going on there. Here's a simplified geological map of Mull and Iona area. This is in Morvern. The dikes are indicated as black lines. Now, these aren't actual real dikes. These are just indicative of where you get them and where they run, what they look like. But the general trend is northwest, southeast, as you can see there. That's absolutely standard. The S&H booklet, Landscape Fashioned by Geology, is really good. It's one I would recommend to anyone who's just starting out to find out about the geology of these places. It's very, very good. There's great diagrams in it. And if you look at the places that have a huge concentration of dikes on the map, this is the Croghan area around here. And you can see the whole coast. There's lots and lots of these red, pink dikes indicated on the map. And also in the Loch na Keal area, you see there's a lot of them down this coast, a lot of them here as well. And these are probably the places I've got the most There are other places as well, but there's quite a few along the coast from North Mull. But if you want to see dykes in profusion, these are the places to go. I mentioned North Mull, and you can see that they've got a different, because this is a newer map, this one, the ornamentation is different. The dykes are indicated by green lines. And you can see there's loads and loads of them all cutting northwest, southeast. One of my favorite places to go is Ardmore, which is up here around this area. And that's a great place to see them. There are loads of them on the shore. Nice and easy to get to, good forestry tracks. If you want to see dykes, that's a great place to go for them, if you're in North Mull. Now, regarding the ages of these things, again, MLS and Bell have got these this chart, this is only half of it, showing the various igneous centres, places where volcanic activity has taken place at the beginning of the Tertiary. And the black line, this is the time scale down the side here, and these black lines indicate when dykes were happening. And as you can see, it's just all the way throughout the entire, for each of the centres, for each of the entire, all these places where igneous activity was happening, dykes were happening. It wasn't just volcanic, lava's pouring out. There were dykes taking place all the time. So that's happening all the way through. If we want to look at them in a bit more detail, the composition, we look at what's called chilled margins and grain size, thermometamorphism, which I mentioned earlier, columnar structure, what's called druses, phenocrysts, lots of good words here, xenoliths, and composite dykes. So I'll show you illustrate some of these, what these things are, because these are all things that are characteristic of dykes. The composition, most of them are of basalt or dolerite. Basalt's a fine-grained rock, dolerite's a bit more medium-grained. There are other possible compositions as well. I'm not going to go into that in any detail. Some of the Permian dykes, and a lot of these in the southwest of Mull and Iona, are of a rock type called lamprophires. Now, I'm not going to get involved with this because these are horrendous things to try and explain, but they are different and they look different. When you see them in the field, they're actually clearly different from the younger tertiary dykes. Here's a quick chart from the Elements of Field Geology by Himmis and Sweeting, and it shows you the basic minerals. There's only a few minerals make up the average igneous rock. Acid rocks like granites and felsites and rhyolites, stuff like this, have quartz and orthoclase feldspar and various micas. Most of the dykes are basic, which means they occupy this zone here. And it's things like plagioclase feldspar, a bit of olivine, augite, maybe some hornblende. That's probably not as much as on here, and iron ores. So they tend to be darker coloured. The rocks on this side of the diagram are lighter coloured. Most of the dykes are a dark colour, and they occupy this part of it. Basalt, dolerite, and gabbro are basically all the same. They've got the same mineralogy, the same chemistry. It's just that basalt is fine-grained, dolerite is medium-grained, and gabbro is coarse-grained. So I mentioned the concept of the country rock and a dyke or a sill cutting through it. When you've got these things intruded into the rocks, where the dyke, the hot material, comes in contact with the cold rock, it cools down a bit. You get what's called a chilled margin. And the effect of the hot dyke on the country rock is to actually heat it up. So you get baking of the country rock and you get chilling of the dyke. So it's, you get these two effects working together. Here's an example of a chilled margin. This is the dyke here. You can see a little offshoot there. And if you look along the edge, you'll see it's a sort of lighter color. It's sort of slightly white. That's the chilled margin where it's cooled against this material here. So it's hard actually getting a good picture of a chilled margin, but this is the best one I could come up with. But they're common on a lot of dykes. Thermometamorphism of the baking of the country rock. Well, here's a cracker of an example. This is at Laganolva. And this rock here, this greyish stuff, is a volcanic ash. And this is a dyke cutting across it. Look how it's made it red. It's reddened the ash either side of the hot dyke. So when the hot dyke came up into this, it's cooked the rock either side. So that's baking of the country rock. Quite common. But it's seldom as dramatic as this. This is a really dramatic example of it. And it's easy to get to as well. I mentioned columnar structure. Now, that 10-meter dike, that 5-meter dike rather, I showed you earlier near Tobermory, you can see the columnar structure here. You're actually looking end on into the columns. So it's, you know, these things have this columnar structure, something that's very well developed. That's what's going on there. It's quite common in a lot of the dikes. I also mentioned things called druses. Now, druses are these little holes up the middle. You see these right down the middle of the dike? It's sort of pockmarked with holes. Now, these are gas bubbles. So as the thing cools down, it cools down from the outside inwards. And there are very often gas bubbles left at the very end of the cooling process. And these solidify as these little voids. So that's what these are. And again, it's quite common in these dikes. Druses. Another thing that some of the dikes, now some of these are spectacular. Some of the dikes in Mull, and probably elsewhere as well, but I know the Mull one's best, have extremely large crystals in them. Now that, you know, that cannon lens cave is about 2 inches across. I mean, some of these things are about 1 inch across. Huge, what are called phenocrysts of felspar in the dike material. And it's caused by a 2-stage cooling process. The feldspars have cooled very slowly at depth, developed into big crystals, and then the dike material has all come up and cooled quicker to produce a finer grained background material. So that's what's going on there. Now, they're not that common, but there's a few of them about. And this is an example of it, a place called Glachvor. And you can see the columnar structure in this one as well. You see these cracks, that's how it's cooled down and given it's like you're looking end on the columns. Another thing you'll find in these dikes are good at bringing up material from depth. And these things are called xenoliths, bits of the country rock that have been broken off and brought up by the hot dike. And these ones have actually come from quite a phenomenal depth. These are reckoned to be from either the upper mantle or the lower crust, these xenoliths. This is at Greben, and it's quite an important dike. It's not particularly spectacular looking, but there's been quite a bit of research done on this. And these are really neat. And here's an example of what's called a composite dike. Now, remember that diagram I showed you earlier with the granite at one end and the basalt at the other? Well, that's both types in here. The interior of this dike is lighter, a more granitic material. Acidic is the way it would be described, a lot more silica in it. But the edges, these bits here, are more like basaltic material. So what's probably happened is the basaltic material has been injected first, and then the acidic material, this light colored stuff, has been injected later. They're not that common, but there's a couple of really good examples in Mull of this sort of thing. So this is a fairly recent outcrop because it's a quarry that was opened by the Forestry Commission. And it's only over the past few years that this has been visible. And again, it's easy to get to. It's quite spectacular. You know, the contrast between the two types is really obvious. And the rock round about is basalt lavas. So that was dikes. I want to have a look at sills now. What are sills? Well, dikes are the ones that cut across the strata. The ones that run with the strata, that are concurrent with it, are called sills. And there are some quite spectacular sills in various places. They're similar to dikes in a lot of respects, but they're intruded underground. You don't see them at the surface unless you've had erosion. So there could be sills getting intruded under the ground, under our feet at the moment, even as we speak. But you're not going to see them until the ground's been eroded down to the level of the sill. Here's some examples of famous sills. There's some real crackers. I mean, some of the sills in Britain are really quite impressive. Here's one, Salisbury Crags in Edinburgh. I'm straying onto Angus's territory here. I'm sure he'll forgive me. That's a brilliant example of a sill. And right in the middle of the capital city as well. So that's pretty good. Salisbury Crags, very spectacular. It's made of a rock called tesonite. In fact, if you do a search online for the word tesonite, a Google image search for tesonite, it's amazing how many images, about a quarter of the images that come up are actually of Salisbury Crags. Here's another famous one, High Force in Teesdale. And this is a sill. This is what's called the Great Whin Sill, this thing here. And you've got this waterfall coming through it. Again, that's a very well-known one, and it covers a huge area. The windsill covers a great big area. That's a great place to see it. Here's one near Stirling. This is the Abbey Craig. And Stirling Castle is also part of the same sill. It's a big massive thing that covers quite a bit of territory. And what you're seeing is the eroded remains of it. As I said, Stirling Castle is built on the same sill as well. So that's a huge one, that. Here's a famous one in Arran. And I don't know if Angus has been there or planning to go there, but this is an absolute beauty. It's the Drummadoon sill on the west side of Arran. And it's a cracker of a thing. Notice the columnar structure to it. This is it's a great example of a sill. Here's another famous one, the Kilt Rock in Skye. This stuff here is dolerite sill. There's quite a few big sills in the Trotternish area of Skye, but this is probably one of the most famous ones. It just looks spectacular. Supposedly looks like the pleats of a kilt, hence the name. So about sills and Mull, well, they're not as numerous as dykes, I would say. There's still a lot of them. They're pretty widespread. There's a famous complex of sills called the Loch Screeden Sill Complex. And there's also some nice stuff about the Loch Screeden Sill Complex. It's been well studied. It's been extremely well studied. A guy called Jeremy Preston did a lot of work on it, his PhD on it, and there's been quite a few papers written on it since. The Loch Screeden Sill Complex sills contain a lot of xenoliths, material that's been brought up from below. And some of these are quite exciting because they contain the minerals mullite, named after Mull, and also some sapphire. Now, the sapphire isn't of gem quality. Well, nobody's found gem quality sapphire as yet, but it's interesting that it's found in these rocks. Here's a wee map. I can't remember where I got this from, some paper or other. And all these little black squiggles that you see there, these are all members of the Loch Screeden Sill Complex. And I mean, that whole area is covered in them. If you look at the BGS map, all this green stuff that you see are little sills. Now, some of them are not that easy to see inland, but on the coast, there's some quite good ones, some excellent ones on the coast that you can see. And this is the south side of Loch Screeden, and again, it's just covered in these little green things. That's these sills outcropping. Now, I've seen a few of them in the field, but some of them are more spectacular than others. So what do the Mull sills actually look like? You might want to ask. So there's a few pictures of them from a few various places that I've been to. This one is on the north side of Loch na Keal, with small dog for scale. And it's this is fairly typical of a lot of these sills. You'll notice the columnar structure again. The columns form at right angles to the cooling surface, which is always the case with dykes and sills. So it produces this very distinctive top surface. It's like this polygons all interlocking. I mean, it's not a very thick one, this. It's less than a metre thick. Dog's quite small. Yeah, no, that's a nice one. And that's right beside the road. It's right beside the lay-by in north side of Loch na Keal, where people stop to look at sea eagles. Here's another one of the Loch Screeden Sill Complex sills near Kinloch, in the south end of Mull. Very, very flat surface on it here. That's quite a neat one, that. Right beside the road, easy to see. I mean, there's quite a few. I mean, you'll see these things all, once you get your eye in, you can see them all the way down the road to Iona. There's lots of these things at the side of the road. Here's a good one. This is at a place called Porthcilvrunan, which is near Glengorham, North Mull. That's Ardnamurchan in the background there. And this is a thin sill here. Again, it's less than a metre thick, just cutting across the lavas. And if you look it up close, you'll see a thing that's quite a common feature with these sills. You'll notice there's this black glassy material. This is extremely fine-grained material, and you get this on a lot of them. It's quite common on these sills. It looks almost like tar in places. You see this black stuff. Now, what on earth is this? You know, it almost doesn't look like rock, but that's what that is. Hand lens for scale. There's another good one. This one's at Greeben. Greeben's a great place to study the geology. There's so much going on there. but you've got this nice sill cutting across the rocks. And this is what the top surface looks like. It's knobbly. Again, you've got the columnar structure, and this is what it's like looking on top of it. That's a nice shadow of me taking a picture of it. Here's one at Tavul. This is one of the Loch Screed Sill complex sills. This is on the way out to the fossil tree. If you're walking out to the fossil tree, you'd go fairly close by to this. And again, the columnar structure is really quite neat, quite distinct. And when you look down on it from above, that's the toe of my boot there for scale. You can see it's like Staffa. It's the same sort of thing, the same principle. As I said, the columns form at right angles to the cooling surface. So that's a really nice sill, that one. It's quite a long hike to get to it, but it's a good one. And you supposedly get sapphire in it as well. I didn't find any when I was there. Here's one that's been well studied. It's called the Trevan na Scura sill near Sgurr, near Bonessan. And you can see the difference in the colour of the rock. This is the sill sort of squeezed into these metamorphic rocks, these rocks of Moyne age, the metamorphic rocks you get in southwest Mull. And this small picture here is just to show you it in a bit more detail, the hammer for scale. So that's a good one. That's been very well studied. And it's got a huge xenolith in it. I mentioned xenolith, big chunks of rock that have been picked up. This is a xenolith that's shaped like the Isle of Wight. Quite a distinctive shape. Quite neat. And that's the Trevan na Scura sill. So is it a sill or is it a lava flow? I've got a nice wee example for you here. I've shown this before in some of my talks because I just love the place. It's called Stakvik. It's west of Iona. There's no sign of the top or the base of it. The rock's dolerite, similar to a lot of the Loch Screed sill complex sills. But you can't say definitively, absolutely, whether it's a sill or a lava flow. I think it's a sill. I'm pretty certain it is. But it does look a bit like Staffa, There's where it is. Stakvik, west of Iona. Awkward place to get to. There's Iona. That's the Ross of Mull. This is what it looks like when you approach it. And this is what it looks like in a Google satellite image. When you get to it, there's this very nice columnar structure. It's really quite an interesting place. And there's a picture here of someone for scale standing. This was a time that we landed on the thing. We were trying to get to the highest point. And it's incredibly difficult. Really, you would need climbing gear to get over some of this stuff to be properly safe. It's a really, really awkward thing to walk on. We did go up another bit to get to the summit, but yeah. So I think it's a sill, but because it's out in the sea and you don't see the base, you can't see the bottom. You can't see the features that would definitively pin it down as being a sill rather than a lava flow. So that's a wee mystery. So that's sills. We've looked at dykes. We've looked at sills. I want to look at cone sheets now. Now, I don't want to spend too much time on this because these are quite tricky. I'm just going to do a very brief talk about them. What are cone sheets? What do they look like? And where are they found? Well, as I said, they're similar to sills in some respects. They can be composite. You can have a granitic interior and a basic exterior. They were originally referred to as inclined sheets. It was Professor Harker, when doing the Skye survey for the geological survey, he found them there and referred to them as inclined sheets. But it was the writers of the Mull memoir in the early part of the 20th century who coined the phrase cone sheets. That's where the expression came from. The word cone sheet came from the survey work that was done in Mull, although they were first identified in Skye. And they're very closely related to the igneous centres, where all the activity is taking place. They're closely related to that. This is what cone sheets look like. Now, this is my own picture. These things here that you see, these flat things, they look a bit like sills. These are cone sheets, and that's at Kilchoan. Now, the great thing about the cone sheets at Kilchoan is they're really, really easy to see. You just step off the ferry from Mull, and they're just right at beside the road. They're extremely easy to find. And the geopark, I've got some nice signage, some nice interpretive panels explaining these things. What you can actually see is it's very well done, beautifully done panels to explain these things. This is a picture from it's from Wikipedia. It's Anne Burgess who took this one. This shows you a cone sheet, and that's another one under here. So they're not particularly thick, but there's a very distinctive appearance. And there's absolutely hundreds and thousands of these things. This is one Simone picture. This is a cone sheet here, and it looks like it's got a dike feeding it. Now I'm just not 100% certain of this, but it doesn't look like it's a dike that's gone so far and been cut off by a cone sheet, because there's no dike on the other side of it. It looks like this dike is actually feeding a cone sheet, which may be, what's actually happening here. It's an interesting place. So that's at Kilchoan. Here's the classic cone sheet image from James Ritchie, who did work on the survey. Ritchie did a lot of work on cone sheets and ring dikes. He's the guy who probably did more work than any on these ring structures you get in the Hebrides. And basically you've got the magma, you've got the hot material down below pushing upwards, and you've got the cone sheets radiating out from it. They're basically conical fractures in the crust that get filled with molten material, but they form as a consequence of what's called updoming. You've got the material down below pushing upwards and generating these fractures. It's actually quite hard to find a better illustration of cone sheet formation. I've hunted all over the web trying to find some, and no, there's not a lot of them about. There are very, very few. So if anybody wants to create a nice little cartoon of cone sheet creation, I'd be much obliged. It'd be good. This is how they appear on the BGS map. Now this is part of Eastern Mull. This is not far from Salon. And these blue things, these pale blue things that you see curving round, those are cone sheets. And there's absolutely hundreds of the things. The map is covered in cone sheets. This is what they look like when you actually get up close and personal with them. This is a cone sheet near Croggan with a very, very well-developed columnar structure. It's a pity there's nothing on this for scale, but it's about a metre wide. Yeah, there are quite a few in the Croggan area as well as Dykes. Now here's a good one. This is near Loch Buoy. This thing here, running up there, that is a cone sheet. The cone sheet is cut by a dike running that way. But the thing is, this whole thing here, these two intrusions, have already been intruded into a rock called granifier, which is a type of granite. And the granite has already intruded into the lava. So the lava is over the top. The granifier, which is round about here, was intruded next. You then had a cone sheet, and then a dike. Sorry, a cough here. So here's another one near Grass Point that shows you a cone sheet, a composite one, different material at the edges from the interior in the cliff. There's a famous rock type called craignurite, and that's what this yellow stuff is, and that's common in the Craignure area, strangely enough. And it's mainly made up of cone sheets. So if you want to see a cone sheet at the Mull Ferry, just look over the pier. The stuff on the shore is craignurite, and it's a cone sheet. So I'm going to finish with a short virtual field trip to Calgary Bay, where we can look at sills and dykes. This is Calgary Bay, famous visitor location in Mull, and there's some great geology to see there in a very short distance and really, really accessible. Here's the geological map. Now the pink stuff is lava, okay, and so is this ochre coloured stuff as well. You'll see there are lots of sort of black and bluish lines going on. These indicate individual lava flows. The dashed lines are faults. But the stuff we're interested in, the green stuff, these are the minor intrusions. Now that's a dike, that's a dike, that's a dike, that's a dike, and that's a dike. And this little curvy thing here is a sill. It's quite hard to represent these things, you know, in 2 dimensions, but that's what's going on there. So we can see some of these in our virtual field trip. So we start off at the car park. You're looking out to the west, out to the sea here, and that's Treshnish Point, and that's Calgary. We can out beyond the bay. And this is the path that takes us around. Now, like I said, easy walking, simple stuff, loads to see. You can just make out a dike running down the cliff there. We'll see that later. That's the famous one. So we head along and we come across one of these dikes that point goes out to sea. Now this is, I call this one the middle dike. There's actually another one, but it's not terribly exciting. But this one stands out really well. Again, columnar. See the way that it's like columns. Somebody once described it as staffa on its side, which I thought was quite a good description. There's another view of it. Classic dike. Lava's around here, and this columnar dike cutting across it. You know, it's just really easy to see. Now you see this on the shore really clearly, but there's absolutely no trace of it on the hillside behind. You know, when you cross the path, this just seems to disappear. So that's what I was saying earlier about sometimes these are easy to follow, sometimes they're not. We'll go a little bit further on. I mean, just like 2 minutes from that. This is a sill. This is the top of the sill here. That's lava up above, and that's the sill underneath. And this is the black glassy margin that I was talking about earlier. There's also a bit of what's called flow banding there as well. So the thing about these things are, the sill is actually younger than the rock that's on top of it. Geologists, I think, of the law of superposition, that, you know, if rocks that layers on top of other layers get younger as you go upwards, unless there's been folding or whatever. But in the case of a sill, the sill has come along later than the lava, and it's been squeezed in between. So it's a thing to remember. And here's the famous dike at Calgary, the famous Calgary dike at the pierhead. There's an old building here. I don't know if it was a boathouse or whatever, or some sort of shed, but the dike has actually been used as part of the wall for this thing. So that's making use of a natural wall-like feature. That's it there. There's another picture of it, nice sunshine. Very distinct. Northwest, southeast it goes, like most of these dikes. Classic Mull dike. You know, this is, you know, if you had to say what is the best example of a Mull dike, I think you'd have to say this one. And it's one that everybody can easily get to see. From the shore, this was taken at really, really low tide. It was an amazingly low tide this particular day, and I was able to get right out here. You can see the dike coming down, but it sort of disappears at this point. You don't really see it cutting across the shore. But then when you come down here, you pick it up again. Now it's funny because these things can have offsets in them. I mean, they don't just continue in a continuous line. You get these discontinuities where it goes down here. It could be, you know, there's lots of earth movements going on, faulting, all sorts of displacement. And so the dike has got a little offset in it here. And you can see it going into the sea. If you actually go up the hill, the dike almost disappears. All there is a little hollow where it runs. So I was talking about sometimes dikes stand out like walls, sometimes they're ditches. You know, this one shows both features. This is on top, that's at that point there, and that is actually the dike rock there. And this hollow is where it goes through. So, I mean, there's absolutely no trace of it here. That's the pier down there. But when you get to the steep bit of the cliff here, it's really obvious. And when you try going further back up the hill, there's no trace of it. There's absolutely no sign of it. And this is on the other side of the bay. There's a very, very similar dike on the other, that's the one at the pier head there. You can just see it in the distance. And there's another one on the other side of the bay. It looks very similar. It looks a similar rock. It's about the same width. It may be the same dike. That may be a continuation of exactly the same one. So Calgary, great place to see these things. And when you look at the satellite image, again, there's the dike coming down the hill slope. There's the old pier, and there it is going out to sea. So you can see there's a definite offset in it. It's not, it's not continuous, but there's no trace of it on the beach itself. That's all. Thanks for watching. And that's a sill in that picture there. That's Ardmore Point, looking over to Ardnamurchan. Thank you.